Let us look at proposition number 6 of works of Archimedes. The proposition says, given a circle or a sector and an area, it is possible to describe a polygon about the circle or sector such that the area remaining between the circumscribed figure and the circumference is less than the given area. So here we have to circumscribe a polygon around this circle such that the area between the circumscribed polygon and the circumference is less than the area of B. So let's see how we can do that. Let A be the given circle and B the given area. So which means we have two unequal magnitudes, A plus B and B. Circumscribe and inscribe polygons C and I in the circle A such that C is to I is less than A plus B is to B. And we have already seen this, how to do it. So I just present it. So let's inscribe the polygon I, and now let's circumscribe the polygon C. We don't know whether this particular circumscribed polygon satisfies the criteria of the proposition. So let's see now. Circumscribed polygon C is greater than circle A, which is in turn greater than inscribed polygon I. Now C is to A is less than C is to I, which is in turn less than A plus B is to A. C is to A and C is to I. If we look at only these two ratios, numerator is the same in both the cases. The denominators are different. So denominator is the area of the circle, and here the denominator is the area of the inscribed figure. So here I is less than A, or in other words, A is greater than I. So if the denominator is greater, that means the ratio is smaller. So that is how C is to A is less than C is to I. And C is to I is less than A plus B is to A based on the construction itself. So which means C is to A is much less than A plus B is to A. And that means C is less than A plus B. Since C and A plus B have a ratio with the same magnitude A. So here denominators are same, the numerators are different. So C, is it greater than A plus B or less than? Once we actually do the proper construction, C would be less than A plus B. Let's look at it in figures. Now A plus B is to A is 1.22. C is to I is 1.23. C is to A is 1.07. Now here if you notice, C is to A is less than C is to I. But C is to I is not less than A plus B is to A. So we have drawn the wrong polygon. So let's start from the beginning. Let's describe a triangle. Circumscribe and inscribe. Here if you notice, C is to I is greater than A plus B is to A. Now let's do for a square. So now again C is to I is greater than A plus B is to A. So let's increase it to pentagons. So now still it is greater. C is to I is greater than A plus B is to A. Now let's increase it once more. Still greater. Let's increase it once more. And let's increase it once more. Now you will notice that C is to I is less than A plus B is to A. So that means we have satisfied this condition of circumscribing the proper polygon. So here C is to A is 1.05, C is to I is 1.17, A plus B is to A is equal to 1.22. So that means C is to A is less than C is to I, which is in turn less than A plus B is to A. Now subtracting A from both the sides, we get C minus A is less than B. So which means area between the circumscribed polygon C and circumference of A is less than the given area B. So again, C minus A is 1.55 and B is 6.2. So C minus A is less than B. So let me change this again now. So now 1.17 is greater than 1.13. So let's increase the number of sides of the polygon. So now C is to I is less than A plus B is to A. So what are we doing in this proposition? We are reducing the gap between the circumscribed polygon and the circumference. So again, let's take it back. Remember, what if we are talking of a pentagon, we can't bring the circumscribed pentagon closer to the circumference because then it will enter the circle. So the only way in which we can bring it closer is by increasing the number of sides of the polygon. With this, we can do whatever be the area that is given to us. We can get it closer and closer till it becomes less than B. So that is proposition 6 of works of Archimedes. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.